To add a progress bar, go to Add Component, then click on Progress Bar. Done, the component was added. Progress bars offer the same basic settings as the other components. The only difference in the basic settings is in the color group. In here you can find this range input. This input determines the track opacity, that is, the opacity from the progress bar path. As you can see, when I change it, only the track color changes, not the progress color itself. This component has two extra group settings. The first one is the tight group. This first drop-down in this group allows you to switch between the progress bar styles. You can have a circular path or a linear path. Let's check the linear first by clicking on it. Done, it changed. You can change the size of a linear progress bar by changing its boundaries, like this, or you can also use the dimension inputs if you wish. Before showing the next setting, let me change the color of it so the boundaries can be more visible. Okay, the next settings we have is the cap style. Cap styles determine how the start and end of a path will look like. For example, the first option here is called But Cap. This style limits the start and end of the path to be inside the boundary. The next one is the round cap. This one will force the endpoints of the path to have a circular shape. It will also draw the endpoints of the path outside the component's boundaries, as you can see. Just in case you need to do any calculation in your project, this part here is a half circle with a diameter equals to the height out the progress bar. The next option is the square cap. Just like the round cap, it will be drawn outside the component's boundaries by a width of half the progress bar height. The next group we have is the range settings. In here you can set the progress. The first input indicates the current value of the progress bar. The 2 second inputs are used to calculate how much of the progress bar needs to be drawn as active. You can set the minimum and the maximum value in here. You can also use tags with a progress bar. For example, let's say we want to show the current progress of the month. For that, we set the value tag to be the current day and the maximum value to be the total days in the current month. Done. In case you want to switch the direction that the progress moves, you can use this input down here. This value determines the initial point of the progress and consequently the direction that it will move when the value changes. Now let's go back to the circular progress and check the differences. Let's remove the tags first. You can see that if I resize the component boundaries, the width of the progress bar does not change. To set the width, you need to use the thickness option here. This value unit is in pixels. In this case, the width of the progress path is 56 pixels. In the range group, you can two new options, the curving and the range. These two settings work exactly like the curved text from a previous video. Let's do a quick recap. For that, I'll add a rectangle of the same size here and center both components related to each other. Okay, so the curving size is the size of a full circle, as you can see here. The start angles indicated which angle the progress should start from, for example, 90 degrees. The angular distance indicates how much angle the circular path should take. For example, if I set it to 180 degrees, it will draw only half of the circle, as a full circle has 360 degrees. It will also draw only the bottom half of the circle, because the initial angle is 90 degrees. In other words, the visible curve path is from 90 degrees until 90 degrees plus 180 degrees, that is, 270 degrees. You can see that even though the size of the curving is unchanged, the component now occupies only half of the square. Once again, that happens because the curving size is the size of a full circle, not the size of the curve drawn. These options here are just predetermined curves. If you click on them, you can see that the start angle and the angular distance changes to fit the design selected. You can see that the progress moves in a clockwise direction. Just like the linear progress bar, you can switch the direction in which the progress moves by selecting another option down here, like this. A progress bar is basically a shape. And just a regular shape, you can set the background to use a gradient. Click on the color input to open the color picker. Up here, select the gradient option. For the circular progress bar, only the radial gradient is available. For the linear progress bar, all gradients types are available. I already explained gradients in another video. Go check it if you want more details on how it works. We already learned how to add an image in a previous video. We also checked how the user can change the image and how he can interact with it. However, the image component can only use the predefined images set by us developers. What if you want the user to add his own images? For that you can use the photo slot. To add it to the watch face, click on Add Component, then select the option Photo Slot. A pop-up will show up. In here you need to select the default image. This image will be used only when no image is added by the user. Just like a regular component, you can change its size, placement, and rotation and even tint it. The only specific setting you have here is the when to change option. The first option will change the image when the user taps it. The second option will change the image after a number of times that the watch wakes up, that is, when the screen goes on or when the watch face switches from AOD to normal mode. For some reason this value is limited between 3 and 10 times, inclusive. You can also select both options, or neither. In case you don't select any option, the image set by the user will be static, in other words, it won't change unless the user set a new image. There are a few things that I need to mention. First, the user can select up to 30 images only. Second, to add the image, the user is required to use the companion app. This cannot be done using the watch itself. Third and last, this component is only available for Wear OS 6 or higher. This means that if you use this component in your watch face, devices that are not running Wear OS 6 will not be compatible. I recommend not using this feature until most of the devices update to Wear OS 6. I recorded this part just to demonstrate how this feature works on the user side. The companion app here is for the Google Pixel Watch. I did not record it using the wearable apps from Samsung because my watch is still running Wear OS 5. Masking is a way of cutting components based on the shape of another component. It seems confusing, but it is not. To show you how masks work, I'll add two components: an ellipse and a rectangle. I'll tint them both just to look better. Tinting is not required to use masks. Okay, now we have two shapes here. To add a mask filter, first we need to select, at least, two components. In this case I'll select the ellipse and the rectangle. Do a right click on any of them, and then click on mask. Or you can use this button up here instead. I'll stick to the right clicking. Done, we created a mask. As you can see here, both shapes seem to have disappeared, only one part of the rectangle is still here. You can also check that we now have a new group here on the left sidebar. A mask group. If you expand it, you will see that both components are still here. And if you click on one of them, they will both show up in the canvas for designing purposes. Note in the preview that the part of the rectangle that is visible is the part that is over the ellipse. This happens because we are cutting the rectangle using the ellipse shape. In other words, the parts that are outside the ellipse area are not displayed. This is also what this arrow, on the left sidebar, is indicating, that the rectangle shape is being cut by the component below it, in this case, the ellipse. This is important, always the bottommost layer that is selected will be the cutting shape. Let's invert this then. To undo the masking, right-click on the mask group, then click on Unmask. You see, the ellipse is under the rectangle. Let's invert this, and repeat the same process. Select both components, right-click, then mask. Now the rectangle is the cutting shape, and the ellipse is just something that is being cut. We can also add more layers here. For example, let's add a green ellipse to the watch face. Then drag it to the mask layer, like this. Now both ellipses are being cut by the rectangle. In case you want to remove a component from the mask, just drag it outside the group. You can mask any component. For example, let's mask a rectangle and a text. This time, I'll use the text as the cutting shape. Therefore, I need to move it under the rectangle, so it can be the most bottom layer. Then repeat the process, select, right-click, and then mask. Done, now only the parts of the rectangle inside the text will be displayed. There are numerous possibilities with this feature. For example, let's add a gradient to the rectangle and set the text component to show the current second. Now you have a text font that has a gradient color. We can even use tags on the rectangle. For example, let's make it rotate. This way the gradient color of the font will change over time, like this. Before showing you how to add the gyro settings to a component, I want to demonstrate how the angles work. First, consider that you are wearing your watch on your left wrist, like this. With that in mind, I'll remove the arm and move the watch here to the right. Here at the bottom, I'll display the angle value for the X and Y axis. The X represents the rotation of the watch for the sides. The Y represents the rotation of the watch around your wrist. Here at the left I'll add a 2D representation of the rotation. Consider the blue dot at the center as if it was the watch orientation. Okay, so right now both X and Y are at 0 degrees. This means that the watch is leveled. It is facing up like the image of the arm I showed you. If I rotate the watch to the left, like this, the X angle will be minus 90. 90 is the maximum an angle can get. In this case it also means that the watch rotated 90 degrees. The minus sign tells us that it is rotated to the left. So, if the value of x is positive, it means that the watch rotated to the right, like this. Remember, 90 degrees is the maximum value the watch can rotate in any direction. It can have any value between minus 90 and 90. I'm just showing the extreme values here. You can see that the y value didn't change while doing these rotations. To change the y angle, you need to rotate the watch around your wrist. For example, if I rotate the watch to face you, like if you were checking the time on your wrist, the y-axis will have a value of 90. Also note that when the watch rotates towards you, the blue dot moves up in the 2D representation, not down. I honestly don't know why they make it move like this. It seems counterintuitive to me, but that's how it works. Now, if when the watch rotates towards you, the y-axis has a value of 90, when it rotates away from you, it will have a negative value, in this case minus 90, and the blue dot moves down. These are the concepts of how the angles work when the watch rotates. Now let's test it out on Watch Face Studio. For that, I'll add a rectangle, I'll set it to have a size of 100 by 100 pixels and I'll center it relative to the screen. Even though I'm showing this feature using a shape, this works exactly the same way with all the other components. Now let's add it. On the right sidebar, expand the gyro group. Then enable the option Apply Gyro. You can see that it added two new groups, one for the x-axis and the other for the y-axis. To add a gyro effect to the x-axis, click on the plus button of the x group, like this. You will see that there are a couple of settings in here. This first half is for when the watch rotates from 0 degrees to minus 90 degrees, that is, when the watch rotates to the left. The other setting is the opposite, from 0 degrees to 90 degrees, in other words, when the watch rotates to the right. Inside each half you will have the properties you can change using the gyro. They are scale, displacement, rotation, and opacity. Let me show you how it works. Let's set the width scale of the first half to be 200%. This means that when the watch rotates to the left, it will scale the shape width by 200%. To test this out, we can use this control here. It works exactly like that one I showed you in the angles demonstrations. Below this control you have two inputs. They will show the angle value while you move the blue dot. You can see that as I move the control to the left, simulating that I'm rotating the watch to the left, the shape width scales and the x input goes to minus 90. But what if I try to rotate it to the right, like this? The shape size does not change. This happens because I only set the effect from the left side. If I wanted to have an effect when I rotate it to the right side, I need to change the values from this half here. For example, let's scale it when I rotate it to the right, but this time, let's change the height instead of the width. Now if I rotate it to the left, it will scale the width but not the height. If I rotate it to the right, it will scale the height but not the width. Let's test the opacity property. Let's set it to 0 when I rotate the watch to the right. Now when I move the blue dot to the right, the height increases and it gets transparent. But it only scales 200% and gets fully transparent when the watch rotates a full 90 degrees in the x-axis. This happens because the height and the opacity values are set to be 200 and 0 only when the angle is 90 degrees. While the angle increases from 0 to 90, both the height and the opacity, in this example, will change the value proportionally to the current angle. So, for example, when the angle is at 45 degrees, half of the total angle, which is 90 degrees, both values will be at half of the value set. In this case, the height will have increased 150%, and the opacity will be at 50%. We can change this angle value. For example, let's set it to 45. Now the height will be at 200% and the opacity at 0% when the watch rotates 45 degrees in the x-axis. To set the gyro effect to the y-axis, click on the plus button of the y group to expand it. It has the same settings as the x-axis, and it works exactly the same way, but in the y-axis. Just remember that when the blue dot is up, the watch rotates towards you, and when the blue dot is down, the watch rotates away from you. That's all for this video. I'll leave some links to official docs in the description of the video.